In this video, we will explain the action of the LPS on the epidermis. It will be easier to understand if you watch LPS Learning 4, Basic Knowledge of Skin and LPS Action. Please watch a separate video for the action of LPS on the dermis. We have conducted various studies on the effect of LPS on the skin. Of these, let us introduce to you items related to the epidermis, shown in red. The skin consists of the epidermis, dermis, and subcutaneous fat. Here, let us explain the action on the epidermis. The epidermis is composed primarily of cells, called keratinocytes. First, please look at the graph on the left. This graph is the keratinocyte proliferation curve, with the horizontal axis representing the number of days of culture and the vertical axis representing the cell count. You can see that the proliferation rate is faster in the LPS-added medium, shown in the blue line, than in the normal medium, shown in the gray line. That is, the addition of LPS to keratinocytes promotes proliferation. Next, please look at the photo on the right. This is a micrograph that shows how keratinocytes move and fill in a circular space over time. The blue area is still blank and the white area is keratinocytes. The upper 6 photos show when cultured with normal media, and the lower 6 photos show when cultured with LPS-added media. These show that the blank area is rapidly buried by keratinocytes in the LPS-added media. That is, when LPS is added to keratinocytes, they move faster. As you can see, the addition of LPS to keratinocytes promotes proliferation and migration. This leads to early wound healing when the epidermis is damaged. When LPS is added to keratinocytes, factors related to barrier function such as filaggrin, fibronectin, and claudin-1 increase. Skin barrier function is related to also skin sensitivity. If the skin's barrier function is normal, stimulants are less likely to enter, and moisture is also retained. However, when the barrier function is decreased, stimulants reach the dermis and cause a tingling stimulus because the dermis has nerves. Also, moisture evaporates more easily. Therefore, when the barrier function is decreased, sensitive skin is likely to develop. So, does LPS improve sensitive skin? This is the results of a study on the sensitivity of skin when a lotion containing LPS was actually used by people with sensitive skin. In this study, 11 women with sensitive skin used lotion containing LPS twice a day for 4 weeks. They rated sensitivity when lactic acid was applied to their cheeks on a stimulus, scores of 0 to 3. The left graph shows the results. You can see that the stimulus score is lower from week 1, compared to before the start of use of LPS. This study also examined stratum corneum hydration and transepidermal water loss. We can see that the use of the lotion containing LPS increases stratum corneum hydration and decreases transepidermal water loss. These show that LPS enhances skin barrier function and improves sensitive skin. Now, as explained in LPS Learning 4, LPS promotes keratinocyte autophagy. Autophagy is a mechanism to self-degrade and recycle unnecessary proteins and structures in cells. It attracted attention because Dr. Osumi was awarded the Nobel Prize in 2016. Autophagy is also associated with keratinocyte turnover. It was explained that keratinocytes move up from the basal layer while changing their morphology, which is called differentiation. Keratinocytes migrate while differentiating, and turnover in about 1 month. Differentiation is caused by the action of autophagy. Therefore, if autophagy is not normal, differentiation does not progress, delaying turnover. LPS has been reported to promote keratinocyte autophagy, so it is expected to promote epidermal turnover. This photo shows an experiment to see whether LPS actually promotes turnover. In this test, the same amount of a fluorescent substance, called dansyl chloride, is first applied to both arms. Dansyl chloride binds to amino acids so cannot be washed away. It is invisible under the daylight, but it is luminous under the UV light. The subjects patted their arms applied with dansyl chloride, with lotion containing LPS on one arm, and placebo lotion on the other arm, in the morning and evening. As a result, dansyl chloride fluorescence disappeared more quickly on the arms patted with the lotion containing LPS. 5 subjects performed this test, and the results were the same for all of them. Here is one case with clear photos. As you can see, LPS is expected to promote turnover by promoting autophagy. Keratinocyte autophagy is also involved in melanosome degradation. As this figure shows, melanins produced by melanocytes are released as melanosomes, and are taken up by adjacent keratinocytes. Melanosomes taken up by keratinocytes are degraded by autophagy. When LPS promotes keratinocyte autophagy, it also promotes melanosome degradation. This photo shows an experiment to see whether LPS actually promotes melanin degradation. The left photo shows keratinocytes that have taken up melanosomes. In the middle photo, LPS is added to them. In the right photo, a reagent that inhibits autophagy is added together with LPS. Among these 3 photos, only the middle one is white. This shows that LPS promoted keratinocyte autophagy, resulting in a fast degradation of melanin. In this way, LPS also helps increase skin clarity. In summary, on the epidermis, LPS is expected to 1. Promote growth and migration and accelerate wound healing. 2. Enhance the barrier function and increase moisture retention. 3. Normalize turnover by promoting autophagy, and 4. Remove dullness. The actin on the dermis and troubled skin will be introduced in LPS Learning 6 and 7. Thank you. Next, please also watch LPS Learning 6 and 7, related to skin.